तो आज की क्लास हम स्टार्ट करते हैं ट्रांसपोज ऑफ अ मैट्रिक्स से। तो राइट डाउन द हेडिंग ट्रांसपोज ऑफ मैट्रिक्स। तो हम किसी भी मैट्रिक्स का ट्रांसपोज कैलकुलेट करेंगे। सो इफ वी हैव अ मैट्रिक्स ए आई जे ऑफ ऑर्डर m क्रॉस n। तो हमारे पास एक मैट्रिक्स है जिसका ऑर्डर है m क्रॉस n, मींस नंबर ऑफ रोज m है और नंबर ऑफ कॉलम n है। देन हम कह सकते हैं ए ट्रांसपोज या फिर ए ट्रांसपोज या फिर ए ट्रांसपोज। ए ट्रांसपोज को या तो रिप्रेजेंट करते हैं ए टी या ए डैश या ए बार। ए ट्रांसपोज जो होगा वो होगा ए जे आई ऑफ ऑर्डर n क्रॉस m, मींस रो के एलिमेंट कॉलम में चले जाएंगे और कॉलम के एलिमेंट रो में आ जाएंगे। दैट इज कॉल्ड ट्रांसपोज ऑफ अ गिवन मैट्रिक्स। तो अगर हमारे सामने कोई भी मैट्रिक्स दिया है जिसका ऑर्डर है m क्रॉस n और उसका एलिमेंट ith रो और jth कॉलम का है ए आई जे, तो उसका ट्रांसपोज हो जाएगा ए जे आई। मतलब जो A12 एलिमेंट है वो पहुंच जाएगा A21 पोजीशन पे, जो A23 एलिमेंट है वो पहुंच जाएगा A32 पोजीशन पे। सो जो Aij एलिमेंट है वो पहुंच जाएगा AJI पोजीशन पे। मतलब नंबर ऑफ रोज बन जाएंगे नंबर ऑफ कॉलम, और नंबर ऑफ कॉलम जो है वो बन जाएंगे नंबर ऑफ रोज। करेक्ट। फॉर एग्जाम्पल अगर हम समझें तो जैसे हमको एक मैट्रिक्स दी हुई है 1 2 3 3 1 1, दैट ऑर्डर इज 2 क्रॉस 3 because the matrix have 2 row and 3 column. Order is 2 cross 3, the matrix have 2 rows and 3 column. अब अगर हम इस मैट्रिक्स का ट्रांसपोज लेते हैं तो जो A ट्रांसपोज होगा, A ट्रांसपोज मतलब नंबर ऑफ रोज 2 है, A ट्रांसपोज में नंबर ऑफ रोज कितने हो जाएंगे? नंबर ऑफ रोज हो जाएंगे 3 और नंबर ऑफ कॉलम हो जाएंगे 2। तो हम कहेंगे A ट्रांसपोज इज नथिंग बट ऑर्डर इज 3 क्रॉस 2। अब ये जो कॉलम के एलिमेंट है, ये रो के एलिमेंट है, वो कॉलम में आ जाएंगे। तो हम इसके एलिमेंट को लिखेंगे 1 2 3 3 1 1, दैट इज ए ट्रांसपोज। क्या ये समझ में आया सबको? ए से ए ट्रांसपोज कैसे करते हैं? रो के एलिमेंट कॉलम में लिख देते हैं और कॉलम के एलिमेंट रो में। तो ये पहला रो था, उसको पहला कॉलम बना दिया, दैट इज सेकेंड रो, उसको सेकेंड कॉलम बना। समझ में आया ट्रांसपोज का मतलब? तो कोई भी मैट्रिक्स है तो उसका ट्रांसपोज हम इजीली कर सकते हैं। एम आई करेक्ट? तो रो के एलिमेंट कॉलम में और कॉलम के एलिमेंट रो में इजीली लिखे जा सकते हैं। करेक्ट। नाउ इफ A and B are two given matrix, A and B are two given matrix, then A transpose is A, that is first result. अगर हम किसी मैट्रिक्स का ट्रांसपोज करेंगे तो A m क्रॉस n से ट्रांसपोज लेंगे तो बन जाएगा A n क्रॉस m। फिर से अगर हम इसका ट्रांसपोज ले लेंगे तो बन जाएगा A n m क्रॉस n। तो वो जो A मैट्रिक्स है वही ऑलरेडी आ जाएगी। A ट्रांसपोज ही दे। सेकेंड रिजल्ट, अगर हम किसी मैट्रिक्स में k से मल्टीप्लाई करें, k इज अ रियल नंबर, और फिर उसका ट्रांसपोज लें, दैट इज k into A matrix transpose where k is any real number. Now third is, अगर A और B दो मैट्रिक्स हैं और आपने उसको ऐड किया या सब्ट्रैक्ट किया और उसके बाद उसका ट्रांसपोज लिया, दैट इज A ट्रांसपोज प्लस माइनस B ट्रांसपोज। और ये तो हमें पता ही है, हम दो मैट्रिक्स को तभी ऐड कर सकते हैं जब दोनों का ऑर्डर क्या हो, सेम हो। So A plus B transpose is A transpose plus B transpose. A minus B transpose is A transpose minus B. अब अगर हमने कहा कि दो मैट्रिक्स हमने मल्टीप्लाई किए और फिर उनका ट्रांसपोज दिया, if we multiply two matrix A and B and then we take transpose, that is nothing but B transpose into A transpose. So अगर हम ये कहें कि हमने किसी मैट्रिक्स को n टाइम्स मल्टीप्लाई किया और फिर उसका ट्रांसपोज दिया, तो इसका मतलब हमने क्या बोला, a into a dot 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 a n times, then we take transpose. So this is nothing but a transpose into a transpose dot 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 a transpose how many times, n times. So we can say this result is a transpose whole power n, where n is any natural number. So these are the properties which we are using for given two matrix A and B. And यहाँ पर जो दो मैट्रिक्स आपको दी जाएंगी वो इस तरीके से इस ऑर्डर की दी जाएंगी कि उनका मल्टीप्लिकेशन, उनका एडिशन, वो सब पॉसिबल होगा, तो आप यूज कर सकते हैं ये सारे रिजल्ट। किसी भी रिजल्ट में किसी को कोई डाउट है? आनंद, काजल एंड करण, एनीवन हैव एनी डाउट? तो रो को कॉलम और कॉलम को रो जैसे ही हम बनाएंगे वैसे ही मैट्रिक्स का ट्रांसपोज हो जाएगा। तो रो के एलिमेंट कॉलम में, कॉलम के एलिमेंट रो में। तो ए ट्रांसपोज का अगर हम दोबारा ट्रांसपोज ले तो ए आ जाएगा। किसी मैट्रिक्स में कोई रियल नंबर के मल्टीप्लाई करके उसका ट्रांसपोज लेंगे तो के ए ट्रांसपोज हो जाएगा। अगर दो मैट्रिक्स ऐड या सब्ट्रैक्ट करेंगे और फिर उसका ट्रांसपोज लेंगे तो वो ए ट्रांसपोज और बी ट्रांसपोज भी आपस में ऐड या सब्ट्रैक्ट हो जाएंगे। ए बी ट्रांसपोज का मतलब होगा बी ट्रांसपोज प्लस इंटू ए ट्रांसपोज। और अगर हम किसी मैट्रिक्स को n टाइम्स मल्टीप्लाई करके फिर उसका ट्रांसपोज लेंगे तो उसका ट्रांसपोज n टाइम्स मल्टीप्लाई। दीज आर द प्रॉपर्टीज बेस्ड ऑन ट्रांसपोज। Done? Anyone have doubt? No? Anyone have doubt on this?
No, sir.
Good. मैंने आपको लास्ट क्लास में बताया था, if we need to find q power 2007, तो अगर हमें q मैट्रिक्स से q पावर 2007 तक जाना है तो मेरा ऑब्जर्वेशन होना चाहिए q से q स्क्वायर से q क्यूब से q पावर 4, and then we observe the pattern and then we write q power 2007. So tell me what is q square? Now what is q matrix they gave in a question? PAP transpose. If we do q square, then PAP transpose multiplied with PAP transpose, then easily we can observe that P transpose into P we need. So first we need to find what is P transpose into P. Now P they gave, that is root 3 by 2, 1 by 2, minus 1 by 2, root 3 by 2. That they gave is P. That they gave is what? P. Now we need to take that transpose into the matrix root 3 by 2 minus 1 by 2, 1 by 2 and root 3 by 2. So if we write, then what is P transpose? Root 3 by 2 minus 1 by 2, 1 by 2 and root 3 by 2. That we are multiplying with root 3 by 2, 1 by 2 minus 1 by 2 and root 3 by 2. Now start multiplication. So if we multiply this, then 3 by 4 plus 1 by 4, 1. Root 3 by 4 minus root 3 by 4, 0. Root 3 by 4 minus root 3 by 4, 0. 3 by 4 plus 1 by 4, 1. So clearly we observe P transpose into P become I. If this become I, so this we can say PA square P transpose. Now again, if we observe Q power 3, so PA square P transpose, that again multiplied with PA P transpose. Again, what is P transpose into P? I. So this become PA power 3 P transpose. Now observe. What is Q? PA P transpose. What is Q square? PA square P transpose. What is Q power 3? PA power 3 P transpose. So that's how what is Q power 2007. PA power 2007 into P. Now we need to write P transpose into Q 2007 into P. Check. We need to write P transpose Q power 2007 into P. So what this value we got? We got P transpose P A power 2007 P transpose into P. What is P transpose I? So this become A power 2007. Correct? Now I told you if A is 1011, then A power n nothing but 10n1. That I told you earlier. So if A is this, A power n is this. Now tell me what is A power 2007? This is nothing but 1, 2007, 0 and 1. Am I correct? Now what they gave? A, B, C, D. So this information they gave is A, B, C, D. Now what is A? 1. What is B? 2007. What is C? 0. What is D? 1. You need to find 2A plus B minus 3C minus 4D. Now what is 2A? 2 plus 2007 minus 4. Then answer is 2000. Can everybody get that? Why we are doing this? Now this result I gave you earlier in multiplication. So if you go through that lecture, then you can have that result. Okay. So here we are using this transpose. Transpose means row become column and column become row. Am I correct? Check. Anyone have any doubt in this question? Observe. Here the question is, M they gave is A transpose B into A. We need to find A M power 2023. What I told you. If we have M and we need to find M power 2023. So first we find M square, then we find M power 3, then we find M power 4, and after that we need to observe the pattern. And by observing pattern, we need to write M power 2023. That is the process. Am I correct? So start. What they gave? They gave M. That is A transpose BA. Now you need to find M square. That is A transpose BA. A transpose BA. So we need to find A into A transpose. That you need to check. Now A they gave. So you need to find A into A transpose. Now what is A? 1 by root 10, 3 by root 10, minus 3 by root 10, and 1 by root 10. Now what is A transpose? For A transpose, this column become row, this column becomes second row. So 1 by root 10 minus 3 by root 10 and 3 by root 10, 1 by root 10. Now start multiplication. Multiplication means take this column, multiply with the row and write. Am I correct? So tell me what is A into A transpose? What is A into A transpose? Anyone? Can we say that A into A transpose is 1001? So we can say that A into A transpose, again we have I. Am I correct? If we get A into A transpose I, then this becomes A transpose B square A. Similarly, what is M power 3? A transpose B square A transpose B A, then A transpose I. So this becomes A transpose B cube A. Now observe the pattern. If we have M power 1, B power 1. If we have M power 2, B power 2. If we have M power 3, B power 3. So what the meaning of M power 2023? A transpose B power 2023 into A. No? Observe. Can we write like this? Now you need to find A M power 2023 into A transpose. So if we substitute M power 2023 here, so this become A transpose B power 2023 A transpose into A. Now what is A transpose? That is I. So this become B power 2023. Correct? Now one result I gave you earlier. If B is 1 minus I 0 1. Correct? The result is this. If any matrix B is 1A 0 1, then B power n is always 1AN 0 1. That you need to remember, that we proved earlier. So here in place of A, what we have? I. So if we have B, then tell me what is B power 2023? That is 1 0 minus 2023 I. So here what the answer we got? Now everybody get that this type question can we solve? So here easily we can observe in this type of question always we need to find A transpose, and A transpose they give I. Some of question we have where we get 2I, 3I, that we can use accordingly. Now anyone have doubt in that transpose thing? Suppose A and B are same order matrix. Now A plus 2B that they gave is 1, 2, 3, 1. And A transpose minus B transpose that they gave is 1, 3, minus 1, 2. Now you need to find A and B. That is the question. Correct? Now how we deal these type of questions? Here one relation we have in terms of A and B matrix, but one relation they gave in terms of A transpose matrix. And today we have the property that A plus B or minus B transpose, this is A transpose plus minus B transpose, or A transpose transpose, that is again A. So if these properties we apply here, so we can say A transpose minus B transpose, transpose is 1 minus 1, 3, 2 transpose. So here we can have A transpose transpose minus B transpose transpose. That is, transpose means row become column and column become row. So the equation we have A minus B, we know what is A transpose transpose A, B transpose transpose B. This we got 1, 3, minus 1, 2. Now we have two equation, one more equation we have A plus 2B, that is 1, 3, 2, 1. If we subtract these two, then A cancel with A. Now we can say minus 3 times of B. When we are subtracting, then correspond element subtract with correspond element. So we have 1 minus 1 0, 3 minus 3 0, minus 1 minus 2 minus 3, -2 -1 1, 2 -1 1. Now what the B matrix we have? 0 0 1 and -1 by. Am I correct? No. If we subtract this B matrix in equation 1, then what is A matrix? That is B plus 1 3 -1 2. So what the answer we got? 1 3 0 and 5 by. So that is A. That is. Can everybody get that? So here think what we are doing. Try to observe. They gave, whenever they gave this type of relation, no, that P transpose is equals to 2P plus I. Then what we need? We need to use, what we need to do? We need to use the transpose property. So for that, we take transpose both the sides. So P transpose transpose, that is 2P plus I transpose. Now we know what is I transpose. That is same as I. Identity matrix transpose is identity matrix. Or we can say, if we have a diagonal matrix, then that transpose is always same diagonal matrix. If we have a diagonal matrix and we are taking a transpose of any diagonal matrix, then we can have the same matrix. So we can write like this: transpose of any diagonal matrix is same diagonal matrix. तो अगर कोई डायगोनल मैट्रिक्स है आपके पास और आप उसका ट्रांसपोज ले रहे हैं, तो उस डायगोनल मैट्रिक्स का ट्रांसपोज वही सेम डायगोनल मैट्रिक्स आ जाएगा. दैट्स व्हाई आई ट्रांसपोज इज ऑलवेज आई. नाउ चेक पी ट्रांसपोज इज पी, 2 p transpose and I transpose is I. Am I correct? Now what is p transpose? 2p plus I. So in place of p transpose we are substituting 2p plus I. So p equal to 2p plus I plus I. Check. So we can say P equal to 4P plus 3I. Now we can say 3P is equals to minus 3I. So what we can have? P matrix become minus I. Am I correct? Now they gave one matrix X. So what is P into X? That is minus I into X. And we know if any matrix multiplied with identity matrix, then we can have the same matrix. We know that A into I is always A. Then I into X become minus X. So P into X is nothing but minus X. Now which of the option is correct? Anyone have doubt? Whenever we have this transpose result, then we need to take transpose both the sides. Then definitely we have the matrix P. If we get the matrix P, then still we can solve. Anyone have doubt? Check. Anyone have doubt? Can everybody get that? Anand, Karan.
Yes, sir.
Suppose I gave one more question. Question is saying if matrix A transpose plus 2A, that is 3, 1, minus 1, 2, 0. A transpose into A, that is 3, 1 and 2, 0. Easy question I need. Then find A. If 2A plus A transpose is this, then find A. I am giving you 1 minute, 30 seconds. So here we are not assuming the matrix A, B, C, D. What we need to do? Take the transpose both sides. Then we can say this become 3, 2, 1, 0. Now we have the result that A transpose of transpose is A plus 2A transpose That we have 3, 1, 2, 0. Now what is A? 3, 1, 2, 0 minus 2 times of A transpose, and we know what is A transpose. That is 3, 2, 1, 0 minus 2A. Substitute 3, 2, 1, 0 plus 4A. Then we can say minus 3A is equals to 3 minus 6 minus 3, 2 minus 2, 0, 1 minus 4 minus 3, and 0. So what is A matrix we got? 1, 1, 0. Can everybody have the answer? How many of you get that answer? Anand and Karan. Now I am giving you one standard result with this. So now after onwards, you can easily deal the situations for this type question. If they give matrix A is A, B, C, B, C, A, C, A, B, then tell me what is A transpose? A, B, C, B, C, A, C, A, B. So A and A transpose are same matrix. Now you need to find A transpose into A. So this become, it means we need to multiply both. When we multiply, then we have A square plus B square plus C square, AB plus BC plus AC, AB plus BC plus AC, AB plus BC plus AC, A square plus B square plus C square, AB plus BC plus AC, AB plus BC plus AC, AB plus BC plus AC, and A square plus B square plus C square. When we have a matrix, this, then matrix multiplication is always this. Correct? Here, that observation depend on symmetric matrix. If any symmetric matrix we have, then always we get the same multiplication this. That we will cover in symmetric and skew symmetric matrix in detail. But here the result what we can have, the result is if A matrix is A, B, C, B, C, A, C, A, B, then A transpose into A, either pre-multiplication or A into A transpose, post-multiplication, both we can write what? Yes. And that directly we can use for future reference. So the element are what? Diagonal element A square, B, A square plus B square plus C square, and rest all element AB plus BC plus AC. So that result directly we can write. What the benefit for this result? Suppose we have a question this. A matrix they gave is 1, 2, 3, 2, 3, 1, and 1, sorry, 3, 1, 2. That is the question they gave. And they asked find A transpose into A. So now we are not multiplying. What the answer we have? We need to find two values. A square, B square, C square, where A is 1, B is 2, and C is 3. So A square, B square, C square, 1 plus 4 plus 9, 14. And what is AB plus BC plus AC? That is 2 plus 6 plus 3, 11. Now answer is 14, 11, 11, 11, 14, 11, 11, 11, 14. That is the beauty of this result. Correct? Now, if you observe the question, they are saying A into A transpose is I. So this they gave is 1, 0, 0, 0, 1, 0, 0, 0, 1. If they gave A into A transpose is I, so diagonal element means what the value of A square plus B square plus C square? 1. And what the value of AB plus BC plus AC? 0. And these two results we are using wherever we need. And accordingly, we can find A cube plus B cube plus C. Correct? So what is this option wrong? How we find A square, B square, C square? Now check. A square plus B square plus C square is nothing but A plus B plus C. That directly we have what? 1. Now AB plus BC plus C is 0. Now we need to find what? This. So how we find A plus B plus C? That is nothing but root over of A square plus B square plus C square plus 2 AB plus BC plus AC. So substitute 1 plus 0, that is 1. And positive means answer is 1. Now how we find A cube plus B cube plus C cube? This is nothing but A plus B plus C into A square plus B square plus C square minus AB minus BC minus AC plus 3ABC. Now we have A plus B plus C, A square B square C square, AB plus BC plus AC and ABC. If we substitute all, then answer is 1 plus 3, that is 4. That's why D option is. And these two identity we have, which we'll use wherever we need. Check, anyone have doubt? Get the concept or not? Trace of matrix. Now trace we can define only for square matrix. So if we have a square matrix of order n cross n, then we can say Aij of order n cross n. Then trace of A means sum of diagonal elements. And earlier I told you, if I equal to j, then element lie on a diagonal. So that is trace of A. Element sum Aii. Means we just add all diagonal element, then we have the trace of a given matrix. Suppose for example, we have a matrix A, 1, 2, 1, 1 minus 1, 2, 3, 4, 2. Then what is trace? So trace is sum of diagonal element. So in the diagonal element 1 minus 1, 2. Then trace is 1 minus 1, 2. Answer is 2. So just we need to add element lie in a diagonal. That is called trace. Correct? Now, if we are saying A and B are two given square matrix, same order square matrix, then we have some results. First result, trace of A plus minus B, that is trace of A plus minus trace of B. Because when we add and subtract of two matrices, then diagonal element add and subtract each other. So if we find trace of A plus B or A minus B, then we are adding diagonal element of A plus B, or we are subtracting adding diagonal element of A minus B. Then trace of A minus trace of B means we are adding A diagonal element with B diagonal element, same thing. Or trace of A minus B means we are subtracting A diagonal element sum with B diagonal element sum, that is sum. Similarly, if we multiply any constant with matrix A, then we are saying the K directly multiply with, if we take K multiply with all a matrix, then that k multiply with all elements. That k also multiply with diagonal element. If we find the trace of k, then we are adding diagonal element k with, we can take common. That is k into trace of a, and k is any real number. Next thing, trace of a transpose. This is same as trace of a. If we take transpose, then diagonal element is always same, because aii become aii again. So diagonal element always same. That's why trace is same. And last, if we take trace of a into b, this is nothing but trace of b into a. So if we generalize this result, so we are saying that is trace of a power n. So a we are multiplying. That is same as trace of a whole power n. If we multiply a n times, then first we multiplying and then we take trace, because trace of ab equal to trace of ba. So if we multiply a or b two matrix and take the trace, then we can say b or ab multiplied and ba multiplication, both multiplication have same trace. And the last thing, that they use this result so many times, that is trace of a into a transpose, or trace of a transpose into a, that is sum of square of all elements in matrix A. For example, if I am giving, suppose A matrix we are giving you A, B, C, D. Then tell me what is A transpose? A, C, B, D. If I find A into A transpose, then what we have A into A transpose? A square plus B square, then AC plus BD, then AC plus BD, and C square plus D square. Now tell me, what is trace of A into A transpose? This is A square plus B square plus C square plus, that is sum of square of all elements. A, B, C, D, all element square sum. That is trace of A transpose. So this. Correct? Now, one more thing we can write. If A is a diagonal matrix, so what is trace of identity matrix IN? That we have is N. N is any natural number. Because in identity matrix, all diagonal element are 1, 1, 1. So 1, 1, 1 added how many times? N times. Where I is identity matrix with order n cross. So these are some standard result which we are using in trace. According to situation, we will use these results. So here what we need to do, just without, if you are finding A and B, then find trace, it's very, you are taking too much time to solve, then very lengthy process you are using. So what we need to do, we need to use the trace property. How we use A? If we take trace of A plus 2B, this we have 1 minus 3 plus 1. If we take trace of 2A minus B, then we have 2 minus 1 plus 2. So trace of A plus B means trace of A plus 2 times of trace of B. This value they gave is minus 1. And second equation, 2 times of trace of A minus trace of B, that they gave is 3. Am I correct? Now we have two equations, two unknown. Easily we can simplify. Am I correct? So we can write trace of A plus 2 trace of B, that is minus 1. 4 trace of A minus 2 trace of B, that is 6. If we subtract, then 5 trace of A is 5. If we add, then trace of A is 1. If we substitute trace of A is 1, then 2 trace of B is minus 2. Then trace of B we have minus. Now what is trace of A minus trace of B? That is 1 plus 1 and answer is 2. Can everybody get that? No need to find A, no need to find B. Just we need to use the trace property. And trace we know sum of diagonal element. Correct? So here one more thing we can use. If matrix A equal to matrix B, then trace of matrix A is equals to trace of matrix B. तो अगर दो मैट्रिक्स सेम है तो दोनों मैट्रिक्स का ट्रेस भी सेम होगा. चेक करो. You read the question, then trace of A easily you can find. Now you need to find A into B into C. So you need to multiply these three matrices. Am I correct? So first you need to observe these three, then BC square, then BC cube. Then observe, here we have BC, that is BC power 2, BC power 3. Then we need to multiply BC first and see what the BC multiplication is. Now observe. What is B into C? 3, 4, 2, 3. 3 minus 2 minus 4. 3. If we multiply this, this becomes 1, 0, 0, 1. Now we observe that BC multiplication become I. No. Then what is ABC? A. What is ABC square? A. What is ABC power 3? A, and so on. So the question becomes trace of A plus trace of A by 2 plus trace of A by 4 plus trace of A by 8 and so on. Now we can find trace of A. In A, what the sum of diagonal element? 3. So this becomes 3 plus 3 by 2 plus 3 by 2 square plus 3 by 2 cube and so on. This is infinite GP. What the sum of infinite GP? A by 1 minus R. Then answer is 3 into 2, that is 6. Check. So here only one thing we observe, that we have 6. Anyone have doubt? So here we are observing only one thing, that BC multiplication is what? Now mostly in this type of question, that BC multiplication relate to I. Here easily get I. Sometimes it is 2I, 3I, that we can manage. So that BC multiplication, we need to focus on BC multiplication. What is this? Accordingly we can think. So in trace, anyone have doubt now? We start singular and non-singular matrix. Singular and non-singular matrix. So if you have a square matrix A, A is a square matrix of order n cross n. Then determinant A is getting 0. That is determinant A. then A is singular matrix. अगर आपने किसी मैट्रिक्स का डिटरमिनेंट निकाला और वो जीरो आ गया तो वो मैट्रिक्स सिंगुलर होगी. एंड इफ डिटरमिनेंट A is non-zero, then A is non-zero. तो अगर किसी मैट्रिक्स का डिटरमिनेंट जीरो है तो वो मैट्रिक्स सिंगुलर है. अगर उसका डिटरमिनेंट जीरो नहीं है तो वो मैट्रिक्स सिंगुलर नहीं. तो अगर हमें चेक करना है कि मैट्रिक्स सिंगुलर है या नहीं तो हम बस उसका क्या निकाल लेंगे, डिटरमिनेंट. अगर उसका डिटरमिनेंट जीरो आ गया तो वो सिंगुलर है और नहीं आया तो वो सिंगुलर नहीं. करेक्ट. जैसे हम आप ये कहें कि फॉर 2x2 मैट्रिक्स, जैसे ए मैट्रिक्स अगर है हमारे पास A B C D, then what is determinant of A? That is product of diagonal element with minus sign, so that is AD minus BC. So we are doing multiplication with A into D, B into C and minus C. Correct. In general, suppose we have matrix A, two, 3, 1, 9. Then what is that A? 18 minus 3, 15. For 2 cross 2. Correct. And rest all case for any square matrix A, determinant of A, that is sum of product of elements in any row slash column, element of any row slash column with its own cofactors. That is called determinant of A. So if for any matrix you need to find determinant of A, then you need to find sum of product of element of any row and column with its own cofactor. Now you are curious, what is the meaning of this cofactors? Correct. So if we have a matrix A, Aij of order n cross n, then for every matrix we have a minor matrix. First, for every matrix we can write minor matrix. So minor matrix we are writing for correspond element. So first, minor matrix for Aij, that is element all element excluding element in ith row and jth column. Now in example I will explain. Suppose we have a matrix A 1 2 1 3 2 3 2 1 2. Correct. Now suppose you write M11. M11 means minor matrix for element Aij. That is Mij. So if we take M11, then you don't need to take element in first row and first column. Then remaining all element we need to write. So M11 means we are excluding element first row and first column. Then what is M11 we have? 2, 3, 1, 2. Now tell me, what is M23? Now we are excluding element second row and third column. Second row and third column. Second row and third column. Then what the element we are writing here? 1, 2, 2, 1. Suppose we are writing minor matrix 3, 1. That is third row, first column. So that minor is 2, 1, 2. Correct? Again, what is cofactor of element Aij? So cofactor for element Aij is minus 1 power I plus j into determinant of minor matrix Mij. Correct? Suppose in the same example, if we write C11, that is cofactor for element 11, so that is minus 1 power 1 plus 1 and determinant of M11. Now we have minus, and what the determinant of M11? So what is M11? M11 is 2, 3, 1, 2. What is M11? M11 is 2, 3, 1, 2. And how we find determinant of 2, 3, 1, 2? 2 into 2, 4 minus 3. That answer is 1. So C11 is 1. Am I correct? No. Suppose we need to find C31. So minus 1 power 3 plus 1. Determinant of M31. That is plus 6 minus 2. That is 4. So easily we can find the cofactor or not. Am I correct? So if we have A matrix, so if we have A matrix 1, 2, 1, 1, 1, 3, 3, 2, 4, and we need to find determinant of A. So any one row or any one column multiplied its cofactor. So one, what the cofactor of that one, what the cofactor of that element. So we are writing A11, C11, A12, C12, and A13, C13. Now start. A11 means 1. What the cofactor of C11? Minus 1 power 1 plus 1. And the cofactor we are writing determinant of 1, 3, 2, 4. Now what the element A12? Now this row, this column left. Then we have minus 1 power 1 plus 2 and determinant 1, 3, 3, 4. Now we have A13. This 1. What is cofactor? For that cofactor, we need to write minor matrix. That is minus 1 power 1 plus 3 and determinant for 1, 3, 1, 2. Now what the answer we have? We need to write the determinant of this, determinant of this, determinant of this. Then we need to write determinant of minor matrix. This, this, and this. So write the determinant. 4 minus 6 minus 2 times of 4 minus 9 and plus 2 minus 3. Now simplify. Minus 2. Here we have plus 10 minus 1. Then answer is 7. Can everybody find? Suppose we find determinant and that determinant getting 0. If we find the determinant and that determinant is getting 0, so matrix is singular. If determinant is non-zero, then matrix is non-singular. Am I correct? Now, suppose I gave a question. Matrix A, that is X 1, 3, 2, 4, X plus 5, and 1, 1, minus 1. Here we have minus 1, and this is X. Now, if A is singular, matrix, find X. The question is saying X is a real. So if any matrix is similar, then determinant must be 0. So what is determinant of A? -1, -4 minus x minus 5 minus x minus x. What we have? -2 minus x minus 5 plus 3. Then we have 2 minus 4. And that they gave is what? Now we have what? 4. So 9x plus 9. Now here we have x square plus 7x. And here we have -6. So we can say x square plus what we have? 8x. X square plus 8x and plus 3 is getting 0. Now can we find x? -8 plus minus 64 minus 12 by then -8 plus minus root under 52 by 2. So x value we have -4 plus minus root 30. Check. Everybody get that?